Again, I left it incomplete there. For the homework that is due today, you only had to do it one way. And I imagine most of the people did it the first way that we showed the other day. That's fine. But as practice, I would encourage you to learn how to do it the second way and the third way and understand why it's like that. Yes?
Do you mind posting this after you're done?
Actually, I did post this already.
Oh, but not you. Like, I think you posted the one with
I posted...
Was the one with the notes on it?
I posted this... These 6 pages on Blackboard.
Oh, okay.
Okay. So what you're going to do is you're going to augment it by adding what I'm about to do now. Okay. All right. So on this here, we have set it up like this. And so what I did was I grounded the top link here. So I grounded the top link. And by doing so, I labeled this link 2, 3, and 4. I looked at the possibilities here. I can't use this force here because that's a ground, and so that force is eliminated. So I have an input force on 3, I have an output force on 3, and I have an output force on 4. Therefore, the natural way to solve this thing is to make 3 as an input and 4 as an output, which means that you want to use the velocity of I34 to set this thing up. So I34 is right here, and if I look at what's going on with 4 here, this jaw is closing like this, and so I'm pivoting about here. So I34 goes this way because I'm using the right-hand rule. And then I know that I13, I've determined it right here. So I know that 3 is turning like this here because it's going this way. Now I would ask, well, that doesn't quite make sense because I got this thing going down and this thing is going down also. But what's going on there is this is going down faster than this is going down. So it's pinching it close. Okay? So that's why velocity of I34 is going off this way. So I've determined that on the input it's coming, so this is the input here. And what's happening is it's coming from the outside world towards the mechanism, so that BB is pressing down on the mechanism here, so that's why the blue arrow is drawn like this. And that's why I have F out going like that, all right? Although it's on an input. And then from 1, 3, I measure this distance, where's 1? So this is 1, 3. So this is R2 in. So from here to here, because what you do is you look at the ground for the input, which is 1, 3, and you measure the distance to the perpendicular of the line of action of that force. So from here to here is R2 in. So that's why I have that. And I cross R into F, so I get a minus R2 in times F out. Over here, I have this input force to contend with. And so what I do is I have R1 in, perpendicular distance here, going to 1, 3. And I have F in here, so I draw my diagram, F in going up, because from the outside world towards the mechanism, my hand is squeezing that thing. And then I have R1 in going like that, so when I cross this into here, I get a negative also. So I want to note that I get a minus a negative omega-3 and negative omega-4. I have a negative R2 in times F out. I have a negative R1 in times F in. Okay, so a bunch of negatives there. So now let's look at the output. On the output, I only have one force, and it's coming from now the mechanism to the outside world. So that's why the red arrow is drawn down like so from this jaw point here. And so I draw that up there, and I measure from 1,4 to here. And so R out times F out, I cross that into there, and I get a negative, another negative number there. Okay? Yes?
How do you never do it from 1,4 and not, I mean, just because we've been doing most of them from 1,3.
Okay, so let me ask you, what's the output on this? What link number is the output? 4. And what ground location is on link 4? 1, 4. Okay, so that's how you do it. You identify the ground that's associated with the link. So in this case, here's link. That's why earlier, because it was the input, it was on 1, 3.
Yeah. Okay.
All right?
And R is always perpendicular to the force.
The line of action of that force. Yep. What else before I write the equation here? Okay, so let me write the equation. So I write power in equals power out. So I look at the sum of the torque ins times omega n equals sum of the torque outs times omega out. Which means that I'm doing minus R1 in times F in minus R2 in times F out times omega 3, which is a negative omega 3, equals a minus R out times F out times a minus omega 4. Okay? So on this, I solve for, so if I look at this, I know that omega 3, how do I usually write this? Just a second. Yeah, so if I write omega 3 over omega 4, that equals I14 of I34 divided by I13 I34. Okay? So let me go ahead and do that. So I'm going to get rid of all these minus signs. We got R1 in times Fn plus R2 in times F out all times my omega 3 over omega 4 equals R out times F out. Okay? So that means that if I take this, I have R1 in times Fn times omega 3 over omega 4 plus R2 in times F out times omega 3 over omega 4 equals R out times F out. So I can take this here and say that F out equals R out minus R2 in times omega 3 over omega 4. This is all times F in. R1 in times omega 3 over omega 4. Did I do the algebra on that right? Yeah.
How do you eliminate all the minus signs? Isn't the right side positive, the left side negative, and then they both became positive?
That negative times that negative.
I didn't see the negative on the
Yep. Okay?
Question.
Yeah.
If the negative signs are always gonna cancel out, can't we, is it possible to live it out like a power equation or?
No, don't do that. Yeah, don't do that. What else on this? Yeah.
This is probably stupid. Is it supposed to be a negative number?
No, it shouldn't be. No, your answer should be a positive value. You think that's negative?
Well, can you start up with that picture? Please? So I guess your ratio would have to be less than 1, because your R out is smaller than your R2 in.
All right, so this right here that's 3.5, right? And this right here is 7.8. And this right here is 3.25. And then 1,4 to 3,4 is 2.5. And 1,3 to 3,4 is 3.5. So if I put those values into here, equals 7.8 times 1,4 to 3,4 over 3.5, right? R out is 3.25 minus R2 in 3.5 times 2.5 divided by 3.5 times Fn. What's the Fn again? 30? So, someone do that for me? exempt from the exam if you give me the numbers.
2730.
How much?
2730. Am I there?
I hope so.
I didn't do it.
222.
You got stuff.
I got 222.
All right, this side. What'd you get?
222.
Yeah, I got 220.
222?
Yeah.
That's probably right. I mean, I was kind of sloppy on the measurements. So, yeah, Mark.
So what would be the range for correct answer and incorrect?
I think that's too far off. I would give me 8 out of 10 on that.
Alright,
So, I have a question for these. Since the circle that we have to draw lines through is like that big, how far off are we allowed to be with like going through the circle?
Oh, that circle? Yeah, you got to try to get in that center of that circle.
Are we gonna have dots in the test, or are they gonna be?
Probably.
Okay. That'll be
Yeah,
pretty good, because I have trouble with that.
yeah.
Doesn't the base of that come out to be negative or minus? In the
I don't think so. You got
3.25 minus.
2.5 divided by, that looks like about 2/3.
I mean, the 3.25 minus
We multiply that before you subtract it.
2.5 divided by 3.5, 0.71 times 3.5 is 2.5. 3.25 minus 2.5 is 0.75. Yeah. So the bottom part's 0.75. Okay? We're done doing math. Okay. All right. So what I'm going to do now, unless you want me to do something else with this, is I'm going to look at the old exam. And I'll go ahead and do that solution for you if you want me to.